going through what everything in that means. A lot of it is very, very similar to what we've already done. Okay, so in the financial models, okay, what it equals, that is the amount in the account. Okay, that is whatever amount is going to be at the account at the end of whatever we're doing. Okay, that is the amount in the account. That is our A. Now, the P, that is in the place of what we normally have is a lowercase a, right? That is the principal amount. That is our initial amount. It is still just meaning the initial amount. Whatever is in front of your parentheses in one of these growth or decay functions will always be your initial amount. Now, we have 1 plus R divided by N. So the R is the same thing that R has been the whole time. It is our rate. It is whatever our interest rate is, and we write it as a decimal. Okay? And that all gets raised to the power of N times T. So our T, still the same thing. It is just time in account. Okay? The part that is different when we compound our interest is that what we have to do with the N value. Okay? So the N that our rate is being divided by and our time is being multiplied by is the number of times that the account's interest is being compounded, right? So it's the amount of times you're taking the interest of the interest in a year. So we have options for that. So if it is annually, how many times is something that's annually? One. Okay, what about semi-annually? Twice. Okay. What about quarterly? 4 times a year. Monthly? 12 times a year. Weekly? How many weeks are in a year? So 52. What about daily? There we go. Okay. So depending on how many times the interest is being compounded will be the number of N you use. Okay. So we're going to look at a couple examples of these. So for number 19, it says Michael invests $5,000 in an account that pays 4% annual interest. How much will be in the account after 3 years if the interest compounds annually? Then it also asks, what if the interest is compounded quarterly? So what we're going to do first is we're going to find the things that go for both, okay? What is the principal or the initial amount? 5,000. What is the interest rate as a decimal? 0.04. Okay. How many years is this we're looking at? 3. Okay. Now, we have to look at 2 separate ways it's being compounded. It wants us to check compounding annually and compounding quarterly. So we're going to start with annually. When you compound annually, what does N have to equal? 1. Okay? So now we just plug all that into the formula. Okay? So A is equal to 5,000 times 1 plus our rate divided by N, which is 1, to the power of N times our time. And then that's what you type into the calculator. Okay, you have to set this up. You have to show this step before you do the answer. Okay, then I want y'all to use your calculator and tell me what that equals. What is it going to be if it is compounded annually? It's what? No.
No. You did not.
What is it?
Oh, shoot.
It's what was that?
0.32.
Did you put this whole thing in there?
5,624.32.
It is $5,624.32.
That's what I got too.
Okay, what happened with your calculator?
I forgot to take care of it.
Aha, there we go. What happened with yours?
Whoa.
Oh, that is plus. Right here in the middle. Does anybody else need me to check their calculator to see what you did wrong?
Oh, I did 24.
Anybody else need to check? Okay, perfect. So you just need to put an extra 0 in there. It's 5,000, not 500. Oh. All right. Now, we have to do the same thing, but this time it is getting compounded quarterly. Okay? So if it is getting compounded quarterly, what is N? 4. So we start with the same equation, except instead of putting a 1 in there, we will change it so it's 0.04 divided by 4 raised to the power of 4 times 3. And check that in your calculator.
Is it 5, 6, 4?
Yeah.
It is going to be how much money?
That's not an answer, Lauren. Okay, I'm sorry.
And 13 cents. It is $5,634.13 compounded annually. Or compounded quarterly. All right. So that is how we set this up. Now we're going to look at 20. Okay. So for question 20, it says Kimberly's family invested $3,000 in a CD for her when she was born. When it says CD, it is not talking about the disc that plays music. Okay. It is talking about a type of investment. Okay. It's a type of investment that's like safer than stocks because stocks fluctuate with the stock market. A CD is like bound by the federal government and the value of a US dollar. Okay. So it's a little bit safe. It's a safer form of an investment account. Okay. But that's what that is. And the interest is compounded quarterly. It tells us right there it's compounded quarterly. It does not tell us the interest rate. I'm going to tell us the interest rate. It is 0.08. It is 8% interest. Okay. For question A, it asks us to find the value of the CD at the end of 5 years. Okay. So right now, what is our principal amount? What do we start with? All right. What is our interest rate? 0.08. What is our time that we're looking at? Now for A, it is being compounded quarterly, so that means N is 4. So now we're going to write this out. So A is equal to, how would I set it up?
3,000 parentheses 1 plus 0.08 over 4.
Mm-hmm. To the-
Parentheses exponent 4 times 5.
There we go. I told you the interest rate. It is not written in the question. I forgot to write it in the question, so I had to tell you it. Yep. And so once you get that, go ahead and put that in your calculator and tell me how much money is in the account after 5 years.
10 to 5 before you answer.
4457.8.
What is my date?
Is it right? Were you supposed to be off?
I did everything. I was scratching my eye.
We did make a finger.
You have to divide it by 4 too.
This is what you look like.
So the N goes underneath the rate and the exponent. The N goes into places. So you have to divide it by 4, raise it to the power of 4 times 5. That should fix it. All right. Now, part B says, what will the value of Kimberly's CD, or will the value of Kimberly's CD be greater after 15 years if it's compounded annually or quarterly? Okay. So what we're going to do is we're going to do the same thing. Okay. But what is time changing to? 15 years. Okay. Is our rate changing? No. Okay. Time is changing to 15. But what 2 things am I going to have to compare? Quarterly and annually. Okay. So if we look at annually, how many times does annually get compounded in a year? Okay. So we're going to switch it. See, N is 1. So we're going to set it up. So we have the amount is equal to 3,000 times 1 plus 0.08 divided by 1 to the power of 1 times 15. So what is that? It is 9,000 and what?
543.
9,500 and what? And 51 cents.
Oh, I did the other equation.
Okay, that's good. Okay, now, so that is if it is compounded annually. We also have to check quarterly. If we check quarterly, what does that change our n value to? Okay, so we do the exact same equation, except we change n to what? 4. Okay, so we will make that a 4 and that a 4. Okay, and what does that equal when we do that?
843 and 9 cents.
We did both quarterly and annually.
Where did that go?
So whenever we are doing any of the compound interest, the only time we have to use these formulas is if it tells us it is being compounded blank. If it does not say the word compounded in the question, you just do a regular exponential growth function. Okay? You have to do this though when it says compounded. Now, we're going to go ahead and look at 6.5. Do it? Yeah, we are. Yeah, we're going to have some practice on it. Okay? Now, before we look at... Yes. 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 Okay, y'all, before we start on 6.5, I want to take a second and I want us to recap something we've already done this year. Okay? So if we have f of x is equal to the absolute value of x plus 2. What did that right there, how did that cause the graph to move? It caused it to move to the left 2. When it is inside the function, it moves it horizontally. Okay, this went left 2. If I had f of x is equal to the absolute value of x minus 2, how would that cause it to move? To the right 2. So whenever it is inside the function, it does not matter what the function is. Okay? As long as it is inside the function, it is shifting left or right. Okay? Now, if it is outside of the function, if we have f of x is equal to the absolute value of x plus 7, that goes up 7. If we have the absolute value of x is, or minus 3, what is that causing to happen? Down 3. If it is outside the function, regardless of what the function is, it will make it move up or down, okay? So we've already kind of done vertical shifts whenever we graph these. We looked at what happens when the asymptote gets moved up and down. That's essentially just a vertical shift, okay? And that's what we're going to start with. So on our 6.5 paper, okay, it says how does the graph of, or how does the value of k affect the graph of f of x is equal to 2 to the power of x? So we're going to compare the graphs of f of x, which is the one that is already graphed in black, okay, to the function g of x and j of x. I forgot to rechange that from f. So this first one is going to be g, and the second one is going to be j. Okay, g, what is happening in the equation for g with that plus 3? It's getting moved up 3, okay? So essentially what's happening is we're taking the value of f of x and adding 3. What is 1/4 plus 3? 3 1/4, which is the same as 3.25. Okay, what is 1/2 plus 3? Okay, what is 1 plus 3?
4.
What is 2 plus 3? What is 4 plus 3? 7. Okay, so we're going to take and we're going to plot these points. So go to -2, 3.25, -1, 3.5, 0, 4, 1, 5, 2, 7. Or, yeah. Okay, and we can very clearly see that the graph got moved how? Up, right? This is the same graph that's just been scooted up. Okay, all of our extra conversations need to stop, okay? Okay, we don't have a long day today if we're quiet. So now we're going to look at J. What is the transformation that happens in J? So which means it's going down 3. Okay, so we're going to take the value of F and subtract 3. What is 1/4 minus 3? Negative 2.75. What is 1/2 minus 3? What is 1 minus 3? Negative 2. What is 2 minus 3? What is 4 minus 3? 1. And then we're going to plot those points. Okay, and we can see that from the black graph that has been moved down 3. That is all that is happening whenever we are doing vertical shifts, is we're just moving up and down. That is the ones that we're going to have to graph. We're going to have to be able to graph our vertical shifts. We've already talked about it. It just moves the asymptote. Okay, so we're just going to make sure we remember what adding k does. So the graph of f of x is equal to f of x to the power 2 to the power of x plus k. Plus k is a vertical shift. And if k is positive, it moves the graph where? If k is negative, it moves the graph down. And then we're going to do 2 examples of these. Okay? So for number 1, we have 2 to the power of x plus 1. What does that plus 1 cause to happen? Up 1. It's outside of our function, so it goes up 1. Now, for number 2, what does the minus 7 cause to happen? So that is all we are looking for when we see a shift. Okay? Now we're going to look at how h affects it. So if we add a h into our exponent with our x, so we are combining it inside of the function, okay? If h is negative, it moves to the right. Okay? If h is positive, it moves to the... Okay, these are the same transformations we have had the entire year. And we're going to keep using those same transformations. Okay, so it's important we know them. So now, if we look at number 3, we have 2 to the power of x minus 3. So the minus 3 is inside the exponent. So it's inside the function. So that moves it to the right. How many? All right. Then in question 4, we have 2 to the power of x plus 6. Left 6. All right, then we're going to do just some more examples. For number 5, what does that minus 3 cause to happen? Is that inside or outside of the function? So it makes it go? Okay, for number 6. Okay, so go left 1. Okay, for number 7, I forgot to add the 5 right there. So what is plus 5? Up 5. Okay. And for number 8, what does the minus 3 at the very end cause to happen? Down 3. Now, this one actually has one other transformation in it. Does anybody remember what happened to our absolute value function when we put a negative in the front of it? It flipped it. What is the math word for that? It is reflecting it across the x-axis. Okay, so that causes it to be reflected across the x-axis. All right, we do have some practice today, okay? So our practice is going to be us looking at 5 compound interest questions and 9 transformation questions. Okay, so I'm going to go ahead and pass it out. Once you get it, start working. You have the rest of class. If you don't finish it, it's homework. Any questions on that?